Good morning. In the last lecture, we talked about how to design hardware Trojan, and we briefly looked at how to talk about the coverage metrics of different Trojan detection techniques. And we looked at how do we look at rare node coverage, rare branch coverage, and the word rareness is pretty much everywhere. We also looked at two use case scenarios in industry, how it is used today for detecting functional Trojan, and as we go along other ways of detection, story would be different. Just to recap, you have a design and then you do some rareness analysis to identify where the attackers are likely to hide. If your threat model is wrong, everything else is wrong. And once you know where attacker is likely to hide through static or dynamic rareness analysis, then you have a set of techniques which I am going to talk today. You have a set of techniques that will provide you some test cases, and this test case based detection or simulation based security validation relies on the assumption that Trojan payload is functional. What non functional looks like, I will come in a moment, and if it makes any functional changes, then you would be able to detect them. And what is the key idea here? Somebody pretending as an attacker in your company, a good employee, would insert a lot of Trojan of different type. Ideally, you as a defender is not supposed to know your whatever method it is. We are proposing some method, you may manually write some more. Are you able to detect all of them, or what percentage of them you can detect? As I said, statistically, if somebody inserts a trigger more than 12 entries in an AND gate, the statistical likelihood is 0. You will not be able to detect, and anytime there is a 16, 20, you can forget about it, right. And as I said, there are usage models also where you have a golden model, then you can simply just see the compare the output and find it. So, how do you insert Trojan and how do you detect them? All these are interesting problem, and that is where the benchmarks come in. The key idea of the benchmark is when you develop a framework for verification, or you are comparing framework from two different companies, let us say Synopsys and Cadence, how do you know which tool is better? If you ask them to do it, then they will run on their design which will make them look good. So, the idea of static benchmarks depends on whom you are asking. In this example, I am saying if somebody is giving you a Trojan detection tool at the RTL register transfer level or the high level, then the likelihood these are covered. What am I showing? So, there is a web page called trusthub.org. If you can go, you can look at now. So, it will give you sample Trojan in different categories. So, for example, where is the Trojan got inserted during specification design, during fabrication, testing, assembly, what abstract, there might be some overlap, what abstraction level that design is. Is it system level? Think of something written at system C or system C transaction level model, more like C, C++. Is it development environment? Is it register transfer level? Is it gate level design, layout, or at the beyond layout at the physical layer? Physical is basically like printed circuit board. Activation mechanism, how do they get activated? The trigger, always on, I showed you an example, always on, and then the triggered, there are more examples on the triggered category. Is it triggered internally or externally? Internally could be time based, condition based, something like that. We kind of created the AND gate trigger, that is a condition based. When certain rare condition is true, then it gets triggered. Externally, again this has to be triggered, but it is based on user input, or if you are looking from inside of a component, another component which is still a, you think of user input. So, if you are considering, let us say if you are considering, let us say a processor memory design, if this is a processor, this is memory, if you are thinking of from processor, you are sending something to activate a Trojan in the memory, if you are looking from the memory side, that would be considered as external. It is all relative perspective. In terms of effect, the payload, how is it? Payload could be you change the functionality, which is what we talked, because it is easier to discuss. Even for the detection, I will focus solely on the changing functionality. Do other Trojans exist? Yes. Do other detection techniques exist? Yes. It is easier for me to explain and hopefully easier for you to understand. Then you can, once you feel comfortable, you can move on to that territory. Degrade performance. So, that Trojan is supposed to slow you down, it will do certain things, your performance slow down. Let us say you are running at a gigahertz, it will make you, may not be megahertz, maybe 800 megahertz. So, degrade performance, leak information, that is actually a change functionality from a Trojan perspective is not that interesting, but leak information is a major objective. Information leakage is a key idea, whether it is a state actor like a country is trying to get information from another country, or it could be a company trying to leak information from another country, that is basically the leak information, right. When a company pays a significant amount of money to a third party to do some analysis, can you figure out all the system on chip in North America and their typical testing time, you know they are actually bribing you to spy on other companies, because they are getting similar requests from every companies, and it suddenly become legitimate for them. They are saying we are hiding information, giving you the average, but your intent is served. You want certain piece of information from other, then you can do membership inference attack and figure out what is Apple doing, what is Intel doing, what is Xilinx doing, AMD doing, you can figure it out. So, where what we call bribing in India, in US that called lobbying activities, that is legal. Bribing is probably legal here, that is why everybody does it. Once it become legal, maybe less people will do it, but whatever it is, that is basically leaking information, right. Denial of service is basically, you know, I mean you overwhelm a system so that it does not perform its task. Let us say an email server, you are sending an email, that server got bogged down, you are registering for or applying to IIT, applying for master's degree, PhD admission, that server is down. You just submit your application, then you do a denial of service, so that nobody else can apply. So, when Dr. Karfa is evaluating, there is only one application and there are 10 openings, you know the outcome, right. So, whatever it is, these are the effects, a lot of effects. Location, where is it inserted? I mean again this could be inserted anywhere in this website. These examples are available, inserted in processor, memory, IO, power supply, clock grid. In terms of physical characteristics, I only described the easy one, functional one. It could be a distribution, it could be a size, it could be a type. Let me explain one more them so that you understand. The functional one changes the functional behavior, parametric one changes the parametric behavior. What does that mean? Power dissipation it changes, thermal behavior it changes. Now, on the surface it may seem to you like okay, what difference does it make? It does, because it comes with a cooling mechanism, how much it can cool. If you can suddenly increase the power portfolio and it become hot, every 10 degree centigrade change in temperature reduces the lifetime of the device by half, 10 degree centigrade, that is it, 10 degree centigrade. So, it can change the power behavior, and if we can talk offline how do we do that. There is a notion of power virus, temperature virus, but whatever it is, it basically do that effect, right. Same thing about layout, violating lot of layout conditions and all that stuff. So, this is I basically tried to give a very simplistic overview of what is out there in Trust Hub. There are many such websites maintained by European Union and other places. So, you can look at it, but if the whole space of hardware Trojan, whether you believe in hardware Trojan or not, some of the attack models applies to other domain itself. So, for example, two areas in security nobody complains, not in a single person. Trojan is like 50-50 split, information leakage and the side channel vulnerability analysis or attack. These two are going to stay there for eternity. How do you compute the leaky aspects of a design? How do you mitigate it, that line of work, and how do you estimate the side channel vulnerability aspect of it, which could be information leakage, and how do you mitigate it? Any questions on this? This is the threat model under which all of these operate. If this is an attacker came with something which does not even remotely fit this, you are not going to detect it, because you did not design for it. Yes, please.
Is there a possibility of hiding one
Is there a possibility of hiding one attack under the pretext? Remember, as an attacker you did not tell anybody. It is not those honest days that Devi Chaudharani used to say, I am going to go and rob your house today at this time with these many people. There is no such thing. Nobody told you that, and as I go along you will see, even if somebody told you, even then you will not be able to detect. Even if they told you where and the trigger size of 10, go and look for a AND gate with trigger size of 10, you will not be able to do it. But yeah, it is possible. Is it possible to make complicated Trojan? Yes, there are. There are so many such Trojans, and if you look at publication, people are coming up with more and more difficult Trojan, and their experimental setup, we ran all the state of the detection techniques and all of them failed to detect it. If you are designing Trojan, that is your objective. If you are designing a detection technique, then you have to compare with other detection techniques, and none of them are capturing 100% of them, that is not theoretically possible. They are capturing 60% of the Trojan, you are like 77. As long as there is an intuition, and as I go along plethora of detection techniques, you will get an idea. Now, if you zoom in, so this is exactly it appears in Trust Hub benchmarks. I could pull in at the lunch time to show you. It has a lot more. So, basically you click any of them and then you would be able to download those benchmarks. You keep clicking what type of trigger, what it is, you just select and then you can download them. Now that we talked about the benchmarks, those are static benchmark. If anybody trying to sell you any tool, they already ran on all these benchmarks. So, static benchmark is good starting point, you can look how and what you can fill it, but from an evaluation of multiple tools it is not a good idea. So, what we came up with the notion of dynamic Trojan benchmarks, which basically means you do not have to give your industrial design to me to evaluate. You can take my Trojan detection technique or compare any two Trojan detection technique, but you have to use some Trojan insertion thing on your design, right, and you can pick and choose. We will show you the parameter space, which is like huge and potentially infinite. From that parameter space, this tool will automatically insert Trojans and they are valid Trojans. That is the catch. You can insert any crap in your design, but it may change the functionality, right, or it could be easily detectable. It will identify the rare places. It will if you tell them I need. So, if I go back a slide, you can tell them I need at the abstraction level of gate effect of degrade performance and this power supply with that many gates and all that stuff you can tell and spell and give parameter, and you can tell them how many Trojans you want. It is like a la carte, which food and all that stuff and which dessert, it will create those many Trojans and insert it in your thing. Now, you can ask two companies to give their tool and see how many of them gets detected. Of course, nobody will rely a Trojan detection tool to kind of insert in their multi-million whatever or $1 billion empire designs. Nobody will do that. It is like you are inviting a snake and feeding milk, but nonetheless this is a possibility for you, dynamic benchmark that you can do and mitigate. But as I said, the key idea is it is not only inserts the Trojan in the right places, right rare conditions, whatever you asked for, and then it also checks feasibility that is actually a valid Trojan. It will trigger, it will do everything, it will do that. So, as I said, the space is huge, what configuration you can ask for, trigger node and the current version of the tool that is available. What is the rareness threshold, how many Trojan, what is the activation mechanism, what is the Trojan effect, functional or leakage and so on and so forth. It does not support all space of possibilities, but it does support a vast majority of them. And here are some silliest example that you can look at your spare time, that if it is always on, then pseudo random generator and how do you and where do we insert. Even in a silliest design, we can demonstrate you that we can enter different sequential, combinational, hybrid, always on, internally triggered, externally triggered, different types of Trojan we can embed. Now that we talked about metrics and benchmarks, which is basically the core concept in any security domain, I want to talk about something, how do you stop an attacker inserting thing with the notion of rareness reduction. There has not been a lot of work in this area, but I will throw some light so that you can kind of get an idea. So, what I am showing is a simple design is computing just this logic expression, and I wanted to show you if you compute statically the rareness, you would see that the rareness is 0.22, the least rareness in the whole design. Ignore or number of signals with less than, if this is your rareness threshold, there is only one signal with that, and that happens to be this one with value 1, right. Now, if you just do optimization of this expression, as you can see, this expression can be optimized, and the optimized version is this particular one. If you implement that, you will realize your lowest rareness is 0.25, higher rareness meaning it is less rare, it is less rare, and if you look at threshold 0.25, there are no signal below 0.25, if that was your threshold. Of course, ignore the all and average, but simply I wanted to show the act of, and it turned out to, we have proven that the most area optimized circuit has the least rareness. If you really want to make things rare, create a lousy circuit. So, then this kind of another opportunity for synthesis, when you are doing area, power, performance, all that optimization, you can squeeze your area, maybe performance is not good. You add more components like parallel ALUs, performance might go up. So, this puts you another dimension. If you want to do security aware from rareness perspective, then this optimization is good. So, one is this discourages attacker from attacking. This is one way I am saying, it's basically I am saying you, right. The rareness is, there are not too many rare signal, so you do not have too many places to hide, right. That is what I am saying. But how do I prove it? To prove that, we run on different techniques. Of course, I did not talk about the techniques yet, but different techniques like statistical testing, which I will talk in a moment, and satisfiability based detection and all that, and you would observe that if you have same design with the lower area, then your detection, so this is the reduced area, then their detection probability or detection accuracy goes up. So, just if you take a specific point, trigger size of, let us just take a trigger size of, what line am I drawing, maybe trigger size of 6, then if with your original area, if the detection accuracy was 60%, with reduced area your detection accuracy is almost 80%. So, using your existing detection tools, your detection accuracy goes up. That is another way of saying it is not motivating for the attacker to insert if rareness is low. So, this is one of the approaches, reducing area. There are many approaches, we looked at many other things, I just want to talk about 2 of them. This is another one, is design diversity. If you are creating adder, all adders are not equally friendly or unfriendly to rareness. So, in this example, so one aspect is still area, the area story still holds for same design. So, if you are looking at carry look ahead adder, the high area story would still have kind of better detection accuracy, and so this side is basically average rareness of most rare 100 signals, but whatever that number is. So, the rareness story is kind of aligns with, so this shows 2 story, one is area has that effect earlier, second thing is same adder, same addition operation, depending on how you implement it, it has a different portfolio in terms of rareness. For example, this particular design I do not remember what it is, it is so in terms of its rareness is 0.6, which is hardly rare, it is hardly rare for particular value, whereas some others are 0.2, for example, this design and this design, I can see what it is, this is carry save adder, carry look ahead adder, half adder. So, different design. So, so we do that for our sorting algorithm, right, depending on performance you choose different sorting algorithm, depending on your rareness, assuming there is no problem with their kind of. So, of course, area also they have a problem, you see this particular design, the area requirement is very high, although although their the portfolio sorry, this one was wrong. So, this dotted line. So, the portfolio wise rare the area is really low, but I am saying it wrong. Rareness is really low, extremely rare, and area is in this case really high for that particular design. Any questions? So, design diversity, area optimization, there are many other optimization opportunities you can do, and you can control rareness, make it unattractive for the attacker to insert trojans. There is another way to demotivate attacker. Any of you know that? Dr. Karfa will cover whole day on it, obfuscation. Because what was the primary objective? Designer has a clear idea of your design, they can simulate it, run it, analyze it, find rare values. If you obfuscate it, confuse the reader, the attacker, and you put let us say few more extra transitions, and you just make random moves, then attacker has no clue what it is computing. Attacker will not be able to figure out what is rare, what is non-rare. So, then obfuscation is another methodology, rareness reduction is one, and some of you guys will come up with other ways to discourage attackers. So, this is you can think of this is design for security solution. So, you are designing something so that it is attack unfriendly. Now, I am going to talk about different Trojan detection method, and as I go along I will introduce many ideas. Each of the idea has publication on AI. I will not get a chance to talk about all of them, but I will talk about during statistical testing I will talk about Shapley value analysis, that is an explainable AI technique, and reinforcement learning, during side channel also few of them, and golden free detection, of course, all of them are based on AI. So, I will sprinkle those, but I will spend some time on throwing the key idea, because machine learning is trying to figure that out anyway. Because first I want to show you how manually you can do it, so that whether you use machine learning or whether you use non machine learning, the technique remains the same. So, here is the big picture what is going to come next. When you want to do Trojan detection, you can do normal simulation based solution, you generate test, run and detect, or you can do side channel based solution, exactly what Dr. Karfa covered earlier, side channel based solution. And even in side channel, depending on what side channel footprint you are going to use, is it current, is it delay, is it electromagnetic emanation, solutions are going to be different, drastically different, I will talk about. Similarly, here itself I am going to show you at least 6 or 7 possible solutions, just test generation. It may seem to you like, well, I just generate test and run and detect the Trojan, try activating the thing, but as you will see, yes and no, and you will see how it goes. Any question on this big picture? We are doing test generation for simulation based Trojan detection, or we are doing side channel analysis based Trojan detection? Yes, please.
One question is, these two methods, can they find the same kind of Trojans, or they are targeting different kinds of Trojans?
Absolutely. So, the question is who is good, who is bad, it is all relative. As I go along, I am going to present the works in the sequence they are published. So, then it may seem to you this is better than them, but as you see next person comes in, and it is not like functional ones were published first then side channel one, it is kind of mingled, although I will present them separately. So, there is no right answer, it is really every solution is trying to improve on the previous solution. So, all of them are equally good or equally bad.
So, what is the key notion of the side channel? What is the side channel of Trojan?
So, side channel of the Trojan is basically, so for example, when you are doing the path delay based, the Trojan insertion circuit and Trojan not inserted or Trojan free circuit has different delay characteristics. We are trying to figure that out, because if you put an AND gate in the path, then that AND gate is supposed to introduce a delay, but that delay is supposed to hide in process variation. How can I expose it? Same thing for the current, if you have 3 gate, 5 gate, they are going to consume or produce extra power dissipation, that is very tiny in the bigger story. How do I amplify that? How do I hide everybody else, ask everybody to come down and only the Trojan gets to shout in full voice? How do I do that? So, that is why I put that down, maximize activity in suspicious region, minimize activity in the rest of the design. That is the key idea. So, that we can whatever technique we are using, electromagnetic emanation, delay or current, we can amplify that. Any other questions? So, now so again assumptions for Trojan activation is basically that AI, the Trojan is activated lower probability and triggers are selected from rare nodes. With that assumption we will proceed. If things change, a story will not change. So, here is a trigger that used ABC and but you do not know whether it used ABC or not. So, if you are trying to detect Trojan, you have to assume A, B, C, D, which are rare nodes based on rare analysis. You have to assume, you have to try to construct trigger for all possible scenarios, and this for 4 nodes 2 to the power 4 minus 1, all 0 is not a scenario, you are not taking any of them. So, 2 to the power 4 minus 1, those many scenarios you have to consider, and for each of them you have to create a test case. How do we create? We will come to that later, but I want to just convey you, if there are n rare nodes, 2 to the power n minus 1 possible trigger condition. And where does this n come from? You simulate, you see how many times it is 0 and 1, you put a rareness threshold, and anybody below that threshold you call them rare. So, in a million gate design, if you have the rareness threshold of 0.1, about thousands of signals would be rare, 2 to the power 1000, you get the feeling. There is no way you will be able to consider all these scenarios and generate test for them. You artificially you can reduce to 0.00001, but you do not know what attacker is trying to do or how many, which signal they are trying to take. But the point I wanted to mention to you, even if you know it is rareness based trigger, the number of possible triggers is exponential, huge. So, you will not be able to try and generate one test for each of them. Yes, please.
To the power n minus 1 possible triggers are there. So, in reality we will take only one of them or all of them?
If you are a defender, you are trying to generate the test, you do not know which one attacker did. So, you have to consider all these scenarios and generate one test for each of them.
So, like the previous example that we have taken for the AND gate, there are 5 inputs. So, only one of them.
Let us not consider previous gate. In this example, this trigger has 3 rare input, but you do not know attacker actually created this, you do not know that. All you know, your design has 4 rare signal A, B, C, D.
Oh.
So, you have to consider all scenarios, because attacker did not tell you I created a trigger of size 2 or trigger of size 3 or trigger, attacker will never tell you, you do not know that. And remember, this is what we are doing design time. The Trojan might not get inserted in design time, Trojan may get inserted during fabrication time. So, you want to generate test now, so that after fabrication when it comes in, you can run the test and you can exactly the way manufacturing defect story. You want to create manufacturing tests even before it goes for manufacturing. When it comes in, you keep running those tests and say, oh well, that wire was drawn correctly, that transistor is formed correctly, tick, 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 tick. You do for all of the millions of lines, same analogy. Go ahead, please.
Sir, for input size n, why 2 to the power n minus 1, why not 2 to the power n?
So, because minus 1 is the one possibility, all 0, that is not even a trigger. All 0 basically means take none of them, then that is not even a trigger. So, and it should not be a surprise, this I showed earlier and I said I will come back to it. So, even a tiny design with 451 gates, think of 451 variables, there are 10 to the power 11 4 even if attacker told you it is a 4 input Trojan, 10 to the power 11 is a huge number. It is solvable, but it is simply if somebody did not tell you, so it is going to be even more, and if we cannot solve something for 400 gate design, think of million gate design, what are you going to do? It is not possible to. So, those many basically input scenarios you have to try. Now, I am going to talk about lot of techniques, and those techniques basically generate tests, assumes it is a functional Trojan, that is the reliable story. So, let us start with the first one. So, this is in 2009, remember 2007 DARPA started funding, this is one of the first or second paper by Professor Chakraborty from IIT Kharagpur. And so, the idea of MERO is multiple rare occurrence, and this came from an idea of Professor Edith Pomeranz's work on N-detect in manufacturing testing community. The idea is very simple, and very elegant. The idea is, if I know what are the rare signal, if this is my design and let us say I have 3 rare signal and let us say I have many other millions of non-rare signal, let me try to make them blue or some color. I have many more non-rare but regular signal. Idea is, let us try to activate each of them n times. So, what am I changing from? Earlier my problem was the number of inputs, this is exponential. So, I cannot try all possible inputs. So, this is not possible. Then I will be trying random inputs, and in the random input I will be keeping them in my front pocket, the ones that activating some of the red ones. If they are activating, if any test activating 2 of them, that is even better. If any of them is activating 3 of them, that is even better. But I only want to keep the ones or maintain the ones that are trying to activate each of the signal. It would be nice if I can maintain a queue of somebody who activates 2 at a time, 3 at a time, 4 at a time, because that is how triggers are. But the counting game in this work is only one of them. I keep a test if it activates one. So, think of every node how many times this is getting activated. Every time you run a test, there is a counter for each of them. You kind of figure out how many times this got activated. Let us say last I ran 10 tests, this got activated 5 times. Now, I ran another test, this got activated. So, I make it 5 plus 1, 6 times it got activated. Every rare signal has a counter. You run a random test, you decide to keep it or ignore it. If you decide to keep it, then increase the counter accordingly, which one it increased. Now, here is my question. Do any of you have a question? Because if you do not ask question, I am going to ask. You run a random test and you after simulation you observe who got activated. Now, what does activation mean? I need to explain that too. I did not explain. Let us say here is an AND gate, one of these signal is output of an AND gate. This is not the trigger, forget about the trigger for a moment. So, activated basically means earlier it was 0, it got changed to 1, or earlier it was 1, it got changed to 0. That is what activated mean. It changed the value, it created a switching or something happened, right. So, that is we call as an activity, right. You apply a test that created an activity there, you increment the counter. Now, that none of you ask question, my question is, we know trigger will not be based on one signal most likely, attacker is trying to make it more rare. So, they will put multiple of them. Why Dr. Chakraborty used one counter, why not 2 at a time, 3 at a time or 4 at a time, a counter of those, because likelihood the trigger would be 2, 3 or 4, that counting would have been better, is not it? Why not? Because the number of counters would be exponential, that would be more accurate, more precise, but if you do 2 at a time, even if your rare node set is 100 nodes or 200 nodes, the number of counter would be exponential. Now, this comes from a statistical theory borrowed by Professor Edith Pomeranz, then they borrowed. Idea is, if you can activate each node n times and in n is sufficiently large, let us say 1000, then the probability of activating the Trojan, does not matter whether it is created using 2 or 3 or 4, goes very high. Take a moment, think about it. We are only observing one person in the society many times, doing some auditing or whatever. Even if multiple people in the society is trying to do something, a terrorist attack, we will be able to find it. But we are not considering multiple people at a time, we wish we could. One person getting activated n times. Can anybody give me an intuition why that this works? Statistical proof you can see later. Sorry, No, 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 not herd immunity. Because when you are activating this n times, it is going to activate other folks too together. So, if the attacker is actually creating a Trojan out of these two, if this is getting activated n times, this is also getting activated n times, may not be at the same time, but the probability of these two getting together activated at the same time goes high. Another way think about it, if think of these rare signals is only on this side of the wall, all other walls are non-rare. Even if I blindfolded and I am throwing a ball to the wall, if I randomly throw the ball to every possible wall, my probability of success is low. Even if I blindfolded, I could turn this way and keep throwing all my balls to this wall, my chances of hitting those rare signal increases. Probability compared to what? Compared to randomly throwing on the every possible wall. So, that is basically the key idea, right. So, n detect relies on the principle that you are trying to activate only the rare one, you do not care about the other folks, because that is not trigger created with, that is one. Second is when I am activating this n times, there is a high likelihood these two or maybe these three together would be activated at the same time. Yes, please. If the thing becomes on, can you check? Okay, go ahead please.
So if it detects, so one trigger can trigger other ones.
May.
Okay.
Statistical likelihood.
Okay.
That is why this is called statistical testing.
Let's say it is. So is it counted?
No, it is not counted, because if you keep counting 2 at a time, 3 at a time, then even if you have 100 or 1000 rare signal, 1000 choose 2, 1000 choose 3, those combinations, if you add it up, that is exponential counter. In real memory, we will not be able to maintain that many counters.
So let's say if I trigger one and it starts triggering others, for a few seconds or for a delay, it creates a chain reaction, right? And then it dies down.
Implement the program
Okay.
with multiple counter in that lunch break, then ask me.
Okay.
Here we are maintaining one counter for each rare signal and counting becomes easy. When you want to do pair or who else it's contributed, the number of counters would be exponential. Any other questions? Okay. So, now that we have that covered, this is the basic one, and the key idea is so you start with a random number and then you want to flip a bit. In this example, we flip the leftmost bit and we observe before flipping and after flipping, is there any change? If before flipping it was flipping one of the red, after flipping also is still flipping the red, we do not want to take that one. That is the mirror philosophy. Same, and we flip here, initially it was doing 1 before flipping, after flipping it is doing 2. So, then maybe we want to keep it. So, exact number how many, that is different, but I am just telling you it is basically a bit flipping algorithm. It is not just what I said initially, you run some random test and keep the random test that you find thing. It is basically you run a random test and if you like it, then keep that version and flip one of the bit. If you do not like it, do not flip that bit, try flipping another bit. Now, does this remind you any of the AI algorithm? Of course, AI was not that popular, later other people published including my group. What algorithm does it remind you? Keep the one you liked, do not keep the one. So, all of these ideas when you read, you will say, oh, this could be applied for AI. We will come back to that in a moment. Problem with statistical approach, or this Mero approach has two fundamental problems. Can anybody tell me what it is? It relies on the principle of n detect, but it is just that in a design of 100 rare nodes, some of them would be extremely rare, some of them not so much rare. So, that is why you will see some of them are really barely covered. So, maybe like 1 times 2 times, some of them are not, you wanted to cover everybody, hit everybody 1000 times, but some of them are covered 1 or 2 times, some of them are covered millions of times. And if you try to make the rarest of the 1000 times, then you have to try trillions of tests, it is not going to work. So, theoretically it is wonderful, practically it does not work, because it boils down to bit flipping, which is exponential by itself. You flip every possible bit. And so, for different design, of course, but what I just said, then this results in the paper is not possible theoretically, but this result is also correct. Can anybody tell me why? What I just said, you take any design, there are rare nodes, you keep counting, even if you go for millions, some of the rare nodes would be millions of time activated, some of your objective is 1000 times to activate each of them, at least 1000, but the rarest one probably activated once or twice, that is the reality. But when you look at the design, these are the ISCA's benchmark, it is reasonably good 80, 70, 80, 90, 100, 90% Trojan detection rate. How come? There is something silly about these toy benchmarks, and I will come to that in a manner, but I just wanted to put that idea in your head that even if something seems impossible, the numbers when you look at, do not assume that is flawed results, it works for those designs and there is a reason. Now, I want to talk about something else. Remember, we are doing the counting. So, when we are working on this problem and we thought, wait a minute, if there are 100 rare nodes, why do we generate millions of test cases trying to activate each n times and hope and pray that my trigger would get activated. If I go back and draw the same diagram, so this was the idea for the next work. If I draw the same diagram, let us say I have 3 rare nodes, why do not I try to come up with one test case that would activate all 3 of them. If I have 100 rare nodes, I will create one test case that would activate all 100 of them. Then does not matter what attacker does, which 3, which 5 the attacker took, my test is guaranteed to cover it. Think for a moment, if I have 3, what I am trying to do, come up with one test, no million, no exponential, no counting, to cover all 3 at the same time. Can I do it? That is a different story. I will come to that in a moment. How do I do it? So, the two extreme, I think I have an animation also. One is the Mero work you look at, where you cover one at a time and hope and pray that actual trigger got activated. Here we are saying you do all at a time and praying is not needed. You cover all at the same time using one test case. Now, if 3 is the total rare nodes in the design, whether the attacker uses one of them, 2 of them, all 3 of them, it does not matter, the test case is guaranteed to cover.
But you may not have test case of such category.
Professors are not allowed to talk. I was about to ask that question, because if you try to cover all of them, because the way design is, such a test case may not exist. There may not be an input pattern which would activate such a, activating such a thing is hard, there may not be an input pattern. Then what do I do? Even before I go there, what do I do? I wanted to cover all of them, I could not cover all of them. So, let us say here are the 4 nodes, ideally I wanted to cover all 4 of them. If I could not cover all 4 of them, I could not find a test that would cover all 4 of them. What is the best I can do next? Anybody else? Most it can cover. So, that is in computer science that is called, let us say I will try 3. So, this 3, that 3, I am sure there are many other possible 3s. The next most is 3 at a time. If that is also I cannot cover or some of them, then 2 at a time. In computer science, what does the algorithm sounds like? What is it called? Huh?
Greedy.
No, not greedy. It is maximal click sampling. These are the clicks, largest possible one. So, basically you are trying to find the largest one, try to activate it, whatever largest you can do. So, maybe you can do these 3 and then this one is left, maybe then you will try 3 or try 2, you are trying to cover those. So, this is the other extreme. So, you still have that story of trigger sampling and all that stuff, but the key idea is, so you are doing repeated maximal click sampling, you are getting those clicks and getting a test case for those and then you do evaluation. And I am not going to get into the detail, you get the satisfiability graph, if you do not know, do not care, it is not. So, you start with the design, get different clicks that are satisfiable and generate test for those clicks. So, it is still two different extreme, and basically then there are proof, you can look at the thing. valid trigger, and so basically you are mapping your Trojan detection problem to click cover problem, and once you map it to the click cover problem, then you find a test to activate that click. I believe I have animation, but let me see how it goes. So, the 4 nodes I was talking about with different functionalities, then you are really what you are doing, you are let us say when you are trying to do this intersection, what you are asking the satisfiability solver, if you remember SAT solver, we gave a bunch of expression, it tries to come up with assignments to variable such that the expression is true. What you are trying to do, this expression and this expression is true. Let me see whether you guys are with me. Where did I get this expression? From here, how did I get this expression? This expression is nothing but looking from the input all the way, computing this function, start from there, go back and compute this function. So, D is equal to, let us say this is T1, this is T2, right, equal to T1 or I do not know how to write or T2, right. Then T1 you are finding this XOR. So, you basically keep pushing those stuff, that is your expression, right. So, theoretically this is a wonderful idea. What do you think is a practical problem? Remember, I ordered the papers in that order, the order they appear. So, it may seem like, oh, this is great, but then I will say what is the problem, then the next one. What is the problem with this approach? In this diagram it looks nice. When you have a real hundreds and thousands of gates, this expression is going to be huge, and giving to any reasonable SAT solver, handling all these conjunctive normal form, their intersection, that SAT solver will fail, even if it is satisfiable. Even finding the time to tell you it is satisfiable, that is going to be a problem. Then there is another problem, maximal, I quickly flip the slide, maximal finding this story is, you see, 3 to the power n, it is not even 2, the number of clicks and all of that, that is also exponential. So, when we started solving this problem, we did not realize the bit flipping exponential problem in the statistical testing, we moved that problem to the click finding problem, click finding becomes satisfiable, that become exponential. So, when you are solving problem facing such a story, in fact, the bigger problem happened here, constructing the satisfiability graph, that itself is exponential. So, we basically borrowed another idea from computer science called lazy construction. So, do not construct the graph until it is absolutely needed. So, all of this stuff we had to do. When you do any research, you will be simply developing the theory and proof stuff, but practically they may not meaningful unless you do lot of engineering effort to actually make it run on large designs. So, there are a lot of animations, but I am going to skip all of them. Basically, when you start with something, your objective is to construct with all 4, and you start doing, you see DAB, it is not based on this expression, you give it to a SAT solver, it will not find a solution, that went red. So, then you walk back and say, oh, forget about B, now let us try DAC, that is also not satisfiable. Then you say, okay, how about DA, okay, that is satisfiable, DA or AD. So, then basically all you covered at this point is this click you covered, but you are trying different ones. So, this is this you covered, you are seeing which of them together satisfiable. SAT solver can find assignments to those variables, so that they are true at the same time. If they are true at the same time, the primary input that makes them true at the same time is basically the input that activates that click, and that is the test case. And if the attacker actually chose this as a trigger, this as a trigger, or these two as a trigger, this test case will work for all those 3 scenarios. So, similarly, I tried constructing for this silly example other ways, and here it is a 3 ABC. So, ABC is earlier we showed AD is satisfiable, now I am showing ABC is satisfiable. So, there is a test. Similarly, we just you can construct and try to give the SAT solver the story, and BD is satisfiable, and so on and so forth. And when you show results, you kind of have to still compare at that point, the mirror was the state of that, you have to compare, and so in terms of your test length, coverage, how much you cover, how much is test generation time, how you are doing compared to state of the art. And so, here is another visual of number of test vectors you keep increasing, and then you see the trigger coverage for random, because these are rare, this is what random is expected to do. We got only 3000, even if you go from million, it may not move much, because those are rare signal by definition. So, then you do Mero, it is going to go up certain number, and then you do 80%. Again observe, in the Mero paper this number is not 40, this is 80, 90 or 70, 80, 90. So, we will show you why that is still consistent. Now, we will go to machine learning, just to give you an idea, anything I talk about here you can apply AI on top of it. So, we just what we did statistical testing on Mero, how you can apply AI on top of Mero. Remember what was Mero trying to do? Take a pattern, if you like it you flip a bit, if you like that bit flip you keep it, otherwise you change it, right. So, typically you could do such a thing with genetic algorithm, or you can do using machine learning. I am going to show you reinforcement learning. If you want to do genetic algorithm, anybody studied genetic algorithm, they are all cousin brothers and sisters, machine learning, genetic algorithm. Anybody knows how it works? Yes.
So, it works with mutations, so we introduce new changes.
We introduce new changes, right. So, in Roman days there was an emperor who basically did not allow any soldier who did not win, if they died in the battlefield, problem solved, that person is not allowed to produce child. Because the idea is if you won in a battle, if you are healthy, then the child you produce that is going to be healthy, you will go to war. So, whether that biologically that is true or not we do not know, but in genetic algorithm any bit you flip, if that bit brings a lot of thing, that is a good choice you want to keep, retain, and subsequently let us say you have 4 bits and think of a tree, you have 4 choices here, this bit flipped from 0 to 1, this bit flipped and so on and so forth, and each of these choices either you keep and that subtree continues for the other bits, or you do not keep it. So, certain choices you keep or allow it to mutate, certain choices you do not keep. In reinforcement learning, before I go there, I want to just summarize what we talked, 2 techniques we talked about. One is simply by statistically create. So, this is the notion is n detect, make each of them activate n times, and this one is click sampling. You basically get the clicks and try to get a text, try to do all of them at the same time, one at a time, that is the idea, too extreme. And so, what is reinforcement learning trying to do? Did we introduce reinforcement learning in this class? We did, right. Which of you can explain me what reinforcement learning do? You learn, it reinforces. Yes, please.
So, in reinforcement learning, firstly we have to define what is the objective. Based on the objectives, then we set the defined rules which will either reward the agent or it will penalize them.
Reward and penalize. Ivan Pavlov's experiment of ringing a bell and dog eating, even the days reinforcement learning was not known, that is basically the idea you get. So, there is an agent, and so agent interacts with the environment, it is a certain action, and the possible action with the environment depending on the story, environment interacts with the state, and then basically if things are going well, then you reward. Think of in this particular story, if a bit flip actually activate certain thing and you want to keep that test, then that bit flip you want to reward or increase the weight. Simply speaking, do not for the subsequent story keep that bit in that state. But if certain bit flip did not help, you just go back, do not flip it, do not for subsequent iterations. If out of these 4 bits you tried changing from 0 to 1 and it did not, you did not like it, go back to 0, and for all other experiments this bit is fixed to 0, that is the basically penalty or punishment. There are many other ways. So, that is basically key idea of reinforcement learning, and what is happening here is, so there is a little more to this. When you do 2 other ideas I have to introduce, when you want to do this reward, how do you compute reward? Remember in Mero they are computing by counting how many it activates. So, this is not the counting game, this is based on scope or Sandia controllability, observability and program. Again you can download it and play with it. Anybody knows what is controllability and what is observability? So, in controllability basically means if this is your design and there is a rare signal in this context, rare signal means can I come up with input assignments or how easy for me to come up with input assignment to change or flip that value, that is the controllability, right. So, you are trying to assign that controllability. Observability is I thought I controlled it, how do I know until I propagate it to the primary output. So, this part is controllability, control, and this part is observe, and this is the key idea of what I am going to talk next on automatic test pattern generation. You control and you observe, right. If I fricked you enough, you might be start crying, but you might close the door and cry, I may not be able to observe. It is controllable, but I could not observe what happened. I threatened you, and are you collecting money from the bank to give it to me? So, I do not know. So, until you give the money I do not know. Here, and this is a key idea which I am going to bring in later for automatic test pattern generation, but for the remaining part of the lecture let me briefly talk about controllability and observability using a simple example. Let us say you have an AND gate, right, and let us bring the context of manufacturing testing. Manufacturing testing, let us assume the threat model, they called it fault model. The fault model is that this particular line is stuck at 0, stuck at 0. So, how is that possible? When the fabrication lab is drawing a line, it might got connected to the ground line. No matter what you do, it is just stuck. Stuck at 0 is one fault, stuck at 1 also another fault. So, to test stuck at 0, and so initial threat model is all the lines are stuck at 0, all the lines are stuck at 1. So, for each of them you have to generate one test. So, if you have a million line, you have 2 million tests, one for stuck at 0, one for stuck at 1, but in reality it is much less than that, because a single test can cover multiple of them. Let me show it to you. If this is stuck at 0, how do I test it whether it is stuck at 0 or not? Remember, I do not have visual access, the boundary is somewhere out there far away, it is fabricated, I cannot see it inside. I know how many gates are there, I know which gate I am referring, what its name, A, B, C, D, E, F, G, I just do not have manual access to see it or probe it. How do I do it whether this is stuck at 0? I have to disprove it, right. If it is stuck at 0, I have to try to make a 1 here. To make it 1, what do I have to do? So, I have to somehow make this 1. So, controllability of 1 here again. So, I have to, this is the cone of logic I am considering, to make it 1 I have to make it 1. So, that means controllability, let us give it a name A, B and C. Controllability of C can be achieved by controllability of A and B, and stuck at 0 test for C, same test will work for stuck at 0 of A and stuck at 0 of B, that is called test compaction. So, this is a full semester course, but I am not going to go through that, but this basic idea I will use later. So, this is the controllability story, you continue this all the way. It is just that life is not that easy, many times you keep going back, there will be conflict. When there is a common logic, this path is saying make it 0, this path will be saying make it 1. Then it is a serious problem, backtracking. This is the controllability problem. Anybody has any confusion about controllability problem? We are trying to make a line a specific value. Why? In manufacturing testing, because it is a stuck at 0 we are trying to do. Now, the observability problem, how do I propagate? We believe we made it 1, we believe, but we do not know that for fact until we propagate to the primary output or to register that we can dump. To illustrate, let us assume there is a output OR gate, okay, and let us say that is the primary output. For this value to propagate, what do I have to make this OR input to? What do I have to make? What value do I have to put it there? There are two, this is a Boolean value, either 0 or 1. How many of you believe this should be placed 1 in a OR gate? How many of you believe this should be a 0? There are two hands, this should be 0, because in a OR gate if this is 0, 0 will propagate, if this is 1, 1 will propagate. If you make it 1, it does not matter what this value is, always output would be 1. So, we have to make it 0. So, to make it 0, it again becomes a controllability problem. So, observability problem for variable c can be achieved by controllability value, let us call it ABCD, the controllability of signal d with value 0. So, this is basically observability, controllability, it just goes, it is a very interesting problem, and this algorithm is used for eternity, right. So, the scope actually does all of this for you, and you do not have to worry about it. There are many other tools, I prefer this, but in the next lecture we will basically use this controllability observability story to kind of solve the other remaining problems. Thank you.